So let's get into dummy variables here. What are the only two values that a dummy variable can take? 1 or 0. Now this is something, especially if you've ever done a computer programming class in any capacity, you've hopefully heard this before. 0 means off, and then 1 typically means on. Another way to think about this in terms of probability is, if you get a 0, that means the event does not occur, and if you get a 1, that means the event has occurred. Right. So that being said, a dummy variable is just an indicator, and they take the values of only 0 or 1 to indicate the presence or absence of a quantity. Presence means that the x value is equal to 1, and then the absence is going to be the x value is equal to 0. They can be included in regressions just like quantitative variables. So notice here they have an example of di as this is like an x variable that is a dummy. So the x variable here that's a dummy is just like you put in 1 if the person's a female, you put in 0 if the person's a male. Let's just suppose for a second that y is like some sort of like a compassion rating. Let's say a psychologist is measuring how much compassion somebody has for children or something. Let's suppose B2 is the slope associated with the dummy variable. If you go from being male to female, if B2 is positive, that means you get an extra bump in your compassion for children if you're a female. So it's sort of worth being a female if you want to have more compassion, so to say. So the dummy variable indicates that instead of one trend line, we now have another trend line, which is just bumped up higher, because it's just you add some constant, and that constant would be like B2, because you just go from nothing here to something here. Now these x's can be whatever else. It can just be square footage, number of bedrooms, number of bathrooms, or whatever. Okay, here's another example. Suppose you want to look at some dummy variables. Let's suppose sales is equal to 300 minus 30 times the price plus 15 times the holiday variable. Price is the price in dollars, but you'd expect if the price, let's call that X1, increases, then there's a minus here. That means the number of sales should decrease, right? Generally, when we look at supply and demand curves, the whole idea is that as price increases, the demand decreases because people don't demand things as much if it costs more. I'm going to call this X2 because this right here is A. You could call this right here B1, which is the first slope, and you could call this B2, which is the second slope. The holiday variable here, X2, is a dummy variable. Either 0 if it's not a holiday, or 1 if it is a holiday. So holiday is just a dummy variable. What that means is, suppose X1 is 0. Suppose we're giving away the pies for free. What that means is, you'd expect your sales to be $300. Now that doesn't make very physical sense, right? If you set the price to 0, you're not gonna make $300. But suppose the price is, I don't know, $10. Then our sales would be 0, because that would be 300 minus 30 times 10, which would be 300 minus 300. So that's not good. What we need to do is we need to set the price so that we get just the right amount, kind of supply and demand. But think about this. If it's a holiday, being the holiday, people want to buy pies more. So a holiday is worth 15 more sales because if it's not a holiday, you put in 0, you turn it off. If it is a holiday, you put in 1 right here for X2. You turn it on. Think about what B2 means. B2 equals 15. On average, sales were 15 pies greater on weeks with a holiday than in weeks without a holiday, given the same price. When you interpret these slopes in multiple linear regression, you assume the other x variables are held constant. That's why we say given the same price, because you're assuming X1 is constant. Does that make sense? The easiest dummy variable you could think of would be 2 levels. This is 2 levels because it's either 0 or 1. which is off or on. Dummy variables can be a little more sophisticated. So let's imagine there's more than 2 levels. Let colonial, which is a type of house, be the default category. And let X2 and X3 be used for the other 2 categories. Let's assume that colonial is the default. So you have 3 different kinds of houses. You either have colonial, ranch, or you have split level. Now let's assume that most of the houses in our data set are colonial houses. So think about this. Suppose you want colonial X2 equals 0 and X3 equals 0. Because what that means is you've turned off the ranch and the split level. If you want a ranch style house, then X2 equals 1, but X3 equals 0. Because what that means is you turn on a ranch house and you're no longer in a colonial. And then finally, if you want a split level, then you want X2 to be 0, and then you want X3 to be 1. So that's kind of the idea. You're always putting in zeros for what it's not, but there's always a default. So the regression equation would, let's say, be this. The y-intercept is b1x plus b2x2 plus b3x3. Notice b1x1 has to do with the square footage, because you'd expect the house price to go up as the square footage increases. So here's when the person actually starts filling it in here. Suppose this is the equation we get. Suppose you get 20.43 plus 0.045x1 plus 23.53x2 plus 18.84x3. So this multiplies x1, this multiplies x2, this multiplies x3. Now let's assume that you have a colonial house. Set x2 and x3 to be 0. So that means this is gone and this is gone for now. So the regression equation just becomes 20.43 plus 0.045x1. It means that for every square foot that the house is bigger, the cost is 0.045 more. Every 1 square foot the house is bigger. It costs $45 more. Now suppose we have a ranch style house. A ranch style house is when X2 is 1 and then X3 is 0. So if we do that, we set this to be 1 and we set this to be 0. The equation becomes 20.43 plus 0.045x1 plus 23.53. What that means is, if you have a ranch style house, let's assume a ranch style house is more expensive than a colonial house on average. It means on average, you're going to pay $23,530 more on average for a ranch style house than a colonial house, because we've turned on the ranch style house. That's all we've done. We've switched from colonial to a ranch style. So now X2 is 1, so we get this additional constant, 23.53. It works less like a slope and more like an additional constant that raises the line up in terms of its y-intercept, because all ranch style houses are larger on average than colonial houses. Now lastly, what if you had a split level house? Then you'd say X3 is equal to 1, and then X2 would equal to 0. And then you would just, again, you'd get rid of this. So that's what we mean by dummy variables. We allow for X to either be 0 or 1.